I just wanted to do a few updates based on a few topics we've had in the past couple of months. We're getting moving away from Meetup.com. It's costing something like 330 Australian per 6 months, and we really don't get much benefit out of it. And the application is not great. So I'm going to be moving away from that. It's a bit of a shame because we're carrying along like 1,000 users now, but it's not worth the money. So they kind of just slipped in a doubling of the fees like a year ago, and it's been a bit painful. So thank you to Damien, who's been footing the bill for that as part of George Robotics. Appreciate that. But we'll move on to something else. Maybe even just advertising Discord and X and whatnot. There's also a suggestion from Andy about a free service to use. I'll take a look at all those, and whatever I use, I'll share on Meetup before we cut the ties, and the usual channels as well. MP build. This is a cute Mid-Journey image about. I said something like, cranes and snakes, and that's what it came up with. Anyway, so MP Build's the tool that I showed last month, which is just a tool I've put together to help build MicroPython. A lot of thanks to Oliver and Andrew and Joss and Hans. Thank you for your PRs and feedback. We're starting to get the basis of a useful tool. So as well as being a CLI application, we'd also like to take it to use as a library as well. Joss, I don't know if you're on today, Joss, but I just wanted to integrate into his Flash, MP Flash tool. Hans wanted to do it as part of the test infrastructure, which we'll have a look at in a minute. But the upshot is that you'll be able to do something like this, where you can just do import as a module and then tell it to build the board that you want with a variant, or you can use the database access. We've got like a little, when you start the application, it parses all of the boards and creates a structure in memory. This is based on some of your work, Hans, to have like a dictionary built in with some classes that represent those boards and variants. So that should make it easier to integrate things. The actual CLI has also gone a little further as well. We're doing things now like displaying the deployment information. So there's a markdown document that's linked to each of the boards. So when you build it at the command line for that document, for that board, it'll display the markdown to explain how to deploy it. So little things like that will make it a more useful tool. So it's not quite ready for widespread release because I am breaking it pretty quickly, but it's getting pretty close. And so Andrew and I are using it pretty much every other day at the moment, and it's proven pretty useful. So yeah, hopefully we'll be able to spread that love soon. Hans, who is on the line, sent me through his tentacles, which he spoke about, was that 2 months ago, I think? So Hans, I'm looking forward to having a chance to play with some of these. He's been kind enough to wire in some of the micros and some of the devices to test on some of the boards. Many of them are blank though, and so we're looking for people to help us do hardware and loop testing for MicroPython. So if anyone's got an interest in doing that, please speak to me.
May I quickly explain how such a board looks like?
Please.
I sent you a link on the chat. When you open this chat, then we will see the details of such a board. So I ordered these boards in China. It's about $12, such a board. So the goal would be that if a developer wants to do hardware in the loop testing, he has just some of these boards in his, just some spare boards that he can assemble. On the lower side, you see the breakout part. There you can assemble, for example, a MicroPython Pico or an ESP32. Yep. And from the top side, you can see the Ubuntu PyTest. There is a USB connection where you can connect a host computer. And just below is a USB hub. And you are using UHub control. You can switch on and off different ports of this hub, which is quite powerful. So it's very a standard hub. And on this hub, there are 4 ports. One port is to the left, which is a MicroPython Pico, Raspberry Pi Pico running MicroPython. And another port is the one to the right, where the device on the test. So for example, when you have an assembled Pi board or a Pico board in the breakout region, you can connect it via this USB connection, and you can power on and off this MicroPython board. And then you have some relays. You see it to the right on the middle. There are seven relays with LEDs. There you can connect whatever you want. For example, typically you have the boot button connected with a relay, via relay. So with the board, you can power on your device on the test and have the boot button pressed or unpressed, which means you have it in programming mode or not. And then to the left, you see there are LEDs where you can see the state, if it's powered on or not, if there is an error or not. And to the right, to the bottom, there is the octobus. So it's everything. It's about an octopus, which has tentacles, because normally you have many tentacles connected. And with the octobus, they can connect together the different tentacles. So you can connect, let's say, such a device on the test with an I2C module or with a scope. And I gave you 2 times, I think 3 or 4 assembled tentacles where I have tests which you can run already against it. For example, you can take Damian's branch where he's working on the Pico, on the new one. And then it takes MP build and builds the different versions. For example, the ARM version, the RISC-V version, and I think this, or it builds these 2 versions and runs the tests against the board which is mounted here. Or you can download the firmware and run tests just again against your firmware. Or for example, there are tests in the MicroPython repo. This set of tests, and I already integrated them that we can run it automatically. And the goal would be then to have in GitHub a self-hosted runner where we can run branches where people do merge requests on this hardware. And this is a discussion which should start soon with Damian and the other core developers, if there is interest in how we could integrate it, how I could help to write tests and so on. So, but the hardware is now in Australia, and we can discuss how we would like to start to test. And questions, feedback?
I mean, I think I'll try and get the boards that you've already sold up. I'll get them running, and we'll use that as a starting point and see where we go from there.
You see that all the boards are connected together now. The goal would be that you have a ribbon cable. I forgot to give you a ribbon cable for this, because when you have a ribbon cable, you can have them apart and really measure on every board with the scope. And when everything is running fine, you just put it together and there is a more compact form. And just give boards to Andrew or Damian or whoever is interested. And I'm just reworked the documentation from Markdown to restructured test, and now the documentation is in an ugly state. But I hope in 2 days it's fine again.
Cool. All right. Look forward to reading it. Cool. Thank you, Hans. I look forward to playing with it. Thank you. Okay, I'll keep going. MicroPython memory profile. So this is Planned Invasion, the company that Andrew and I work at, have agreed to release the memory profiler. Adrian, this is based on some of the work you've done in the past. So it's an in-house tool that Damien originally had written, predominantly Damien had originally written, where we were looking for fragmented memory from a device. I should actually show you. I've got a video. So the point here is that we can capture a log. And so if you look at this image here, this is the output of what happens, but there's kind of 2 parts to it. You run a little bit of software on the device to record a memory snapshot, and it records that periodically, every 300 milliseconds or whatever you determine is important. And you generate a log, and that log's interleaved with your regular application log, as well as snapshots of what the memory is doing as it runs. As a post-processing step, you feed that log into a renderer, and it generates, in this case, a video file. There's other renderers we could build, but right now it creates a video file where you can see as the video progresses, the log increasing in detail as log detail gets output. And then on the right-hand side, you'll see the memory map, and you'll see it change. And so you can see here, there's like a red bit. That's because since the last frame, that's the area that changed. And so perhaps if I will show a quick video, I should have prepared this a bit better. But we can do this. Use the render. I know I'm not sharing yet, but I will get there, folks. P4 file gets generated at the after the rendering step, and you can see as it goes on, the log file spitting out. Now on the right hand side, you can see this is the memory map that you get from MicroPython.meminfo that we've captured in that log file. And you can see I've actually got two async loops here, one which is allocating blocks of text or blocks of memory, another one which is releasing it less periodically. So you can sort of see it filling up, and then the garbage collector comes in and recovers it. And so that's what the memory profile does. And it's very helpful for finding where you've got fragmented memories, because you need to get rid of that if you want your device to last a long time. So I'm very grateful that PI have given us the okay to release this. Very useful tool for the community, I hope. We've polished it up a little bit. I've got some documentation to go with it. There's a repository to go out. I expect that to go out in the next week or two. There's a link already. You can go have a look at it. Andrew and I are still reviewing and tying it up, but hopefully you guys can use it. Yeah, it's a bit hard to see from this image, but if you've ever done a meminfo with MicroPython, yeah, you can do it. If you pass a parameter to meminfo, you'll get that detailed log that you see on the right there. And it's like there's an ASCII breakdown about what each of the blocks, how it's been allocated. So you can see if it's like a byte array or if it's various objects. So you get quite a lot of detail out of it. Yeah. Good. Right, so some headlines from over the past month. The Raspberry Pi, the 2350, there was all this excitement about all these devices that were released, and it is still a really nice chip, but unfortunately there is a bit of a nasty hardware issue that's been found. So you might hear it referred to as Errata 9 or E9, that's what they're calling it in the data sheet. So Raspberry Pi are documenting this as they're finding out more information, but it has to do with GPIOs and putting them in input mode, and with leakage current overwhelming the internal pull downs. So this is a problem for certain applications, particularly like touch inputs, where you've got that kind of sensitivity to inputs. But this is still an emerging issue, I suppose. Good details on Hackaday, at least they're quite clearly written. So I would, there's tons of stuff being reported online. We'll just keep an eye on this problem and see how it goes. PyCon, I think we mentioned last month that Damien and I have both got talks that were accepted, which is great. I'm looking forward to that. It'll also mean that I'll probably have to dial down my efforts into putting the news together for the next couple of months, just while I focus on that talk. But the other thing is, it'd be good to do a sprint day. So we're looking at probably hosting a sprint day or two, which usually occurs after the main conference, so on the Monday or the Tuesday. So for people here, if you're interested in attending that, let's put our heads together and see what we might want to do for that day. Might be useful. We also spoke about Expressi Dev Con. This is Expressi's conference that was earlier this month. I just wanted to let you know all of the talks are now available on YouTube. And there's some really good ones. They're well produced. They're pretty well delivered. So we've been looking at, there's a talk from Gabor from the LVGL community, and some of the core developers that do the IDF development, for example, which was pretty good to watch. My favorite segment, Matt's new hardware. Not a lot this month, but a couple of potent ones, and we did cover these last month. But the Expressi P4, which came in a really fancy sort of box. I just wanted to show because there's also quite a large broken bit of hardware.
Just the camera.
Quite a large display that comes with it, and it's MIPI connected. Pretty potent hardware. Although I only got a couple of boards this month, they are pretty grunty. The other one is the 230 board, which we did talk about last month as well. This is also another grunty little thing that's designed to do a lot of vision sort of stuff, whether you want to display things or have, it can handle like 3 camera inputs. Very powerful sort of hardware, gig of RAM, that sort of stuff.
Does it run Linux?
No, well, it probably could,
but there's less powerful Linux boards.
Yeah, but O1 Studio, they publish a MicroPython variant, which
right.
integrates some of the OpenMV stuff. It does look a bit hacked together, but it generally works. So it looks like. So yeah, I'm looking forward to playing with it a little more. So the K230 it's a powerful little chip. I just don't, 1.6 gig dual core micro. Yeah, I don't know what to do with this thing yet, but it's interesting enough that I thought I should have it and have a play.
Run some badly written JavaScript via WASM.
Yeah, yeah. Definitely a good host for the WASM stuff. Okay, so in hardware news, M5 Stack had a few announcements. They've released another Atom S3 board. This one adds 8 meg of PS RAM. They already had one of these little atoms running an ESP32S3. This one just adds a little bit more to it. And costs an extra $2. And then the first of its kind is a camera built into the Atom form factor as well. So the S3R cam. Basically rip the display off this one and throw in a camera instead, and that's what you've got. So there's those couple of things. That's about $20, an extra couple of dollars again. I bought a couple of hopefully they'll come next month. Yeah.
Next micro project you might that camera going onto a display in another one.
Well, you never know. Well, that's interesting because Tiny USB had a release where they've one of the things they've added was USB, whatever the camera protocol is.
Oh, really?
In the base of it, so we could have access to it. You never know. And they also released a couple of motors, which is the first time I've heard them do something like that. Wow. So these motors are kind of interesting. You got an STM32 driver inside them with the RS485 or an I2C interface. They've even got a little display on the back of them as well, which is kind of interesting. So you can use that for configuration of the device. And the 2 different modules that they have, the more expensive one has this thing on the front, which allows you to connect Lego to it. I'm not sure why they chose Lego for this kind of device, but there you have it. But the more interesting thing is it's a bit hard to see, but there's actually a Grove port on the bottom there. And so that spins with the whatever you've connected to. This is the whole front end here spins. And so they've got like a slip ring, and you can actually have a Grove connection to the device that's turning. So the cheaper module doesn't have that front end bit with the slip ring. So that's cool. Pretty interesting little motors. I mean, yeah.
Snippets or DC?
DC, yeah, brushless DC. Yeah. So,
wow.
Yeah. And the controller allows you to specify the rate of return. Like it looks like it has profiles as well for ramp up and ramp down, but haven't dug into it a lot yet.
Just got an encoder on it.
I bought one. They're actually they're out of stock now, but it's got an encoder in it as well. Yeah.
Oh, 10 of them.
Yeah, I thought people would like them. Yeah,
access robot.
They look pretty cool. Anyway, if you're into motors, looks like an interesting one to take a look at. $30 for the light module in US and $37 for the one with the slip ring and the Lego access to the front. Okay, Make a Diary advertised this NXP IMX RT range. It's a great little so why am I interested in this? NXP make a good series of chips based on their RT crossover series. So the RT1011 is a 500 meg Cortex M7, pretty grunty. This thing's got 128K RAM and 16 meg of flash. So it's actually at the low end of the scale for the RT range, but $15. And it's in a neat little package. So if you want to dip your toe in the NXP RT world, probably a good one to dip the toe into. I didn't give a photo of this one, but the Cyron IO Controller. I will actually open it up. You can see someone's said something in the chat. Yeah, thanks for reminding me, Stuart. Someone did do a port of the Raj Pi Lego build hat, and they're looking for testers too. I'll include that link in the notes. But just to keep on topic, yeah, this is the Cyron device, and I thought it was really interesting because they've made a few industrial devices before, but they've all been sort of Linux based. This is the first one that's microcontroller based, and they've got, I think it's a handful of like inputs and outputs that are all isolated, and there's an RS485 port that's isolated as well, and they've got Ethernet control, so DIN rail pluggable, pretty wide range of power as an input, so pretty neat, especially for $65 is pretty good value, I think. And they're advertising MicroPython support. Okay, so in other news, we've got Kevin McAleer, who's does some great work in the MicroPython space. Had a recent video about comparing C++ to MicroPython, which you want to don your fireproof suit. It's definitely going to be controversial. So yeah, you go have a look at that. It's interesting. Raj Pi also released this. If you want to do any board layout with KiCad for an RP2040, this book is really clear, a really good introduction to laying out a board with KiCad. Another nice thing about this is it was released with support in a Humble bundle. So if you haven't seen the Humble bundles before, they often package a bunch of like-minded products from various companies. In this case, you get a whole handful of books, and this is one of them. And the whole bundle costs like $35 for including that book. So, or you can buy it for £14.99, which is probably about the same price. MicroPython was also released for the Flippy Zero, which is kind of big news in that community. Flippy Zero is a very popular hardware device. If you know what that is, you should be excited by this. It's available on Flipper Labs, so you can just, it's kind of like the App Store for the Flippy Zero. If you don't know what Flippy Zero is, don't worry about it, unless you're in Canada, in which case you shouldn't be using them because they're banned. That's it for the news. In final thoughts, I just had this ball joint that I just loved. I couldn't get it out of my head. And so I know that people here are going to enjoy it. It's from a couple of years ago, but it's done a great job of making that work. And now I want MicroPython to control that. But anyway, that's a whole nother thing. Is it exceptionally good? Just to quickly show a little bit more. Really good video on how the system actually works. So even if you're interested in doing instructional videos, watch this for some inspiration. It's really clever. Anyway, it's probably coming through terribly online, but it's very cool. Chat. Oh, thanks, Vladimir. I'll mention that in a sec. That's it. I created another Midjourney image just because it's fun. So MicroPython climbing all over PCBs. Yeah, there you go. So that's all I got for you this month, folks. Any questions?